Hey, wake up.
Wake up.
This is the ROS Developers Podcast, episode 104.
The ROS Developers Podcast, the ROS Developers. The ROS Developers Podcast, the ROS Developers.
Hello, ROS Developers, and welcome to the ROS Developers Podcast, the podcast that gives you insights from the experts about how to program your robots with ROS. This is Ricardo from The Construct.
And this is Miguel, also from The Construct. Today we're going to, it's a very special podcast because we're going to do it live on the ROS Dev Day Conference 2022. Between Ricardo and I, we're going to interview the guest, but also remember that you can do questions, make questions to the guest in the tab of the questions there, in the Q&A questions. Yep. So when you want, just put the question and vote for the ones that you like best, and we'll try to accommodate your questions as it flows.
Yeah, and we would like to dedicate this episode to all those people that are thinking that maybe it's time to switch from ROS1 to ROS2. So if you think that maybe this is now the year where you have to be thinking about learning more about ROS2, preparing your robots with ROS2, creating your projects in ROS2, then this episode is dedicated to you.
Great. So let's go with Olivier Michel. Olivier is the founder and CEO of Cyberbotics, the company that develops Webots simulator. He's been developing Webots for more than 20 years, so we can say that it's a product, a very mature product.
Yep, and Olivier is ready to answer our questions, but also your questions. So start writing your questions on the chat tab. Then let's welcome Olivier. Olivier, welcome to the podcast.
Thank you. Hi, Ricardo. Hi, I don't remember Rodrigo, right?
Miguel Rodriguez.
Miguel
Ángel Rodriguez, yeah.
Yes, it's the names and the surnames in Spain and
old Roberto Rodrigo.
Yes, Rodriguez.
The Google Meet is on Ricardo Gonzalez, so I was not sure.
Yes, okay, no problem. Then here we are for you. So let me start, Olivier, about I would like to know how long has Webots existed?
So actually, you said 20 years, but it's a little bit more. It's like we started in '96 to develop it at EPFL, and we released version 1.0 in '98. So which makes almost half a quarter of century, 25 years.
Wow.
Wow.
Awesome.
That's very mature, for sure.
Yeah, but and then at the beginning, when you started to develop this, it was a proprietary software. Well, at the beginning, it was a research project, because I know that you started like this. Then you decided to create this company, Cyberbotics, in order to deliver this product as something professional. It was proprietary software. But then in 2018, you decided to change the license to open source. So what motivated you to do so, and which type of license has?
So basically, we had, I would say, three different motivation. So the first one was customer requests. So we had some of our clients requesting us to access the source code of the software to ensure they could use it and maintain it on the long run. So it was necessary for them, otherwise they would choose another solution. So we decided, well, that was something that for them, we gave them the source code, although it remained proprietary, but that was something that started the reflection for us. And then, some other customers say that having their simulation as open source software would allow them to have a wider distribution. That is, they could give it to many people, and they wanted to do that. And other said that they would need to be sure to have the right to have some commercial exploitation of the software, and they would need an open source license or a license that allows them to mix their code with proprietary code so that they can exploit commercially the result. So that was the first point. The second point is the fact that open source software usually benefits from a large community, bringing testing, bug reports, bug fixes, contribution, spreading the words, and so on. So that was something nice. And the third point is that we actually love open source software. So it was time to go. So in the first months following this move, it was difficult because we lost all the money from the sales of the licenses. And that was a big loss for the company. And we had to fire one employee because we could not pay the whole team. But after 1 year, thanks to a new customer coming because we were using open source software, we could hire back one more employee and then even more.
Wow.
And yeah, that was a difficult move, but at the end of the day, we don't regret it so far because it allowed to grow again on this market.
Awesome.
Very
impressive.
Very
Yes.
brave.
Very brave also, yeah. And then the license that you put as open source, what does it allow us to developers and entrepreneurs to do?
Yes, so this is basically the Apache 2 license, which is the same as in ROS. And this license allows you to do whatever you want. Basically, you can develop open source software. You can also develop commercial software, proprietary software. You can mix it with commercial closed source software. So everything is permitted as long as you maintain the license. That is, you need to keep the license file with what you're distributing.
Okay.
But it doesn't prevent any kind of use. This is the same strategy used by the people at the Open Source Robotics Foundation to avoid blocking industrial application using their software.
Okay. And then, so we have this Webots software that is a 3D simulator for robotics. We are going to learn more about the things that it can do along this talk. Then one of the things that I would like to know is which programming language supports Webots. So how can we program the robot in the simulation?
Yeah, so we provide basically several interface with different programming language. The first one is the C programming language, but you can also program obviously in C++, Python, Java, MATLAB, and we also provide a ROS interface. This is for programming the robots, but in Webots, you can also program the objects. That is, you can have a scriptable object, like it could be a robot with a variable number of legs, and one parameter of the robot is the number of legs. And then if you change it, it will regenerate a new shape, a new robot, new device, and so on, according to the parameter you set. And this implies that you have to program this regeneration of objects. And the programming of this can be done in JavaScript and Lua.
Lua, okay. Okay, and then let me remind the audience that they can put some questions. So you don't have to wait for this podcast. You don't have to wait until the end to put your questions. You can start putting the questions right now, and we will be jumping from our questions, Miguel's and I, and your questions on the chat. Okay, so go ahead.
There's a question from Lucas Macha.
Okay, so I cannot see it here yet.
Yeah, it says, maybe a first question, how well does Webots support integration with ROS2? I'm currently using Foxy. What are the current limitations for using ROS2? That's basically the question.
So we have a pretty good support for ROS1 and ROS2. Currently, Webots is just distributed as a package for ROS2, Foxy, Galactic, and Humble, and Rolling as well.
Wow.
So whatever your distribution is, you could install the latest version of Webots directly from the ROS package manager.
Okay, so basically very good support, actually.
Yeah, we provide also a tutorial, which is on the official ROS2 documentation website, which will explain you step by step how to get started with Webots simulation with ROS2.
Okay, can you share this link? Do you have it at hand now?
Yeah, give me a second.
Yes.
I will get it.
Okay, yeah, because I think now is the moment. So the audience is there,
Yeah,
and then you can get the links, the clicks on the link, and also for the audience is very important because they are here now and they can get this information right now.
Yeah.
And in the meantime, so let me check for the next question.
Okay, I posted the link in Google Meet.
Yes. So Alberto is going to copy that link and put it on the chat for the audience.
Okay.
Thank you, Olivier.
So basically, that is the link for Foxy, but from there you can easily go for Humble and other distributions.
Okay. Then the next question that I would like to ask you is about how important do you think that is having a close to reality simulation for robotics development?
Well, I think this is fundamental. Otherwise, simulations are pointless. I think if you take, for example, a camera image in a simulator, and this camera image is not realistic, then it will be super easy for you to program object recognition, to program the behavior of the robot depending on that object recognition. But when you will move your control program onto a real robot with a real lighting condition, with shadows, with noise, and so on, it will not work anymore. And this is why we are taking care in Webots to provide a very realistic camera device, for example, that includes shadows, noise, optical aberration, motion blur, distance blur, and so on, to have a very high quality sensor modeling, very realistic, so that all the difficulties you will have to tackle in simulation for recognizing object or recognizing the pose of an object, all those difficulties, you will tackle them in simulation, and when you will transfer to the real robot, it will be much, much easier to adapt it to the real conditions.
Yeah, because it will be more or less the same, right?
Yeah, yeah.
Okay.
So we have done some experiment with that, especially with the camera of the Epoch robot. And we were very surprised with the quality of the transfer. That is, the behavior you get in simulation is very, very close to the one you get on the real robot. And that was mainly due to the quality of the camera simulation. The image were realistic enough so that image processing is very much the same in simulation and in the real world.
And do you have any paper, any result that is showing those that you are measuring? Because you remember that so many years ago we did a paper together about this, about measuring the differences between the simulation of the eyeball robot and the real robot, and how the simulation was so close to reality.
Yeah, that's right. Unfortunately, we didn't publish any new papers since then, but we should indeed.
Okay,
But, I hope some users will make some publication. There are more and more publication about Webots, about people using Webots. Hopefully somebody will publish something on that topic as well.
Okay, then for the audience that is there, if you're interested, you can contact Olivier. Maybe you can do a very interesting work, maybe an internship, or maybe your thesis for the final project of your studies. Doing this interesting, I can tell you because I did it with Olivier also, and then it was very, very interesting, and we got some interesting results, and it resulted in a publication in a cited journal. Important. So
yeah. Also take into account, I've been inside the Git of Webots, and they are really, really active. So it's a very active Git repo. So don't worry, there'll be people to help you, because I see it all day. They are doing changes every day. So
okay, great. So it's a live project. Yeah. But Olivier, you mentioned about the realism of your simulator in terms of visual reality. I mean, looking very realistic in terms of vision, of perception. But what about in terms of physics? So how realistic do you think that having a physics simulator is, rather than looking more realistic?
Yeah, I think it's not a matter of looking, it's a matter of rendering realistic camera images, which is important. Whatever it looks is, from aesthetic point of view, but it's not interesting from a scientific point of view. Now, from a physics point of view, I think this is equally important to the realism of camera images, because if you have got wrong physics, then the behavior of your legged robot will not transfer well in the real world. You don't have good contact properties if you don't have frictions,
exactly,
if you don't have, correct mass distribution, and so on. And this is super important. And actually, we are using, like all the simulator out there, fast physics engine, which come from video games, so like Bullet, ODE, and so on. In Webots, we use ODE, which is actually a modified version of ODE, because we had to fix quite a few bugs. We also improved the number of contact point and location of contact point. This is super important for grasping scenario.
absolutely.
And we also introduced fluid dynamics in ODE. So we have actually quite forked ODE, and we are now pretty satisfied with the results. But that's not the only thing. I believe that if you want to have a good result, you need to have a good physics engine, which is one point, but you also need to have a very good model of your robot, which means the model of your robot should be calibrated against the real robot for the mass distribution, for the friction, for the strength of the motors, and so on. And once you've a well-calibrated model with a pretty good physics engine behind, then you can be pretty confident that the results you will get in simulation will be very close to the one you would get on the real robot. But you don't have to forget the quality of the model. So in Webots, we provide a number of example models, like we provide eyeball robot, we provide NAO, we provide U-bot, and so on, which are pretty well calibrated. But if you want to create your own robot, then you should consider spending time in making a good calibration of that robot. Otherwise, the result will not transfer well, and it will be pointless.
Makes sense.
Okay, so we have questions from the audience. Stefan Nesser asks, could you, for newbies, outline the differences between Gazebo and Webots, please?
No, I'm sorry. I don't use Gazebo, so I'm not an expert. And I really don't know the detail of the technical differences between Gazebo and Webots. What I can say is the feedback I'm getting from users, and especially some users which are switching from Gazebo to Webots. And they tell me,
actually,
what's good, what's not. And so the feeling I get is that Gazebo is maybe better integrated with ROS, with the ROS ecosystem, because it comes from here. But they, like recently, I read a paper from some people who design a crawling robot. So the robot was designed in Gazebo, and then they decided to port it to Webots. And the result was that it was running 20 times faster in Webots.
Wow.
So, yeah, that was surprising for me as well. And the thing is that this was a robot with a track, and we have a track model in Webots, which is pretty much optimized. And apparently this is not the case in Gazebo, but I cannot tell you more detail. The result is that those people published a paper saying that, well, they were super happy to move to Webots because of the performance they got. Okay. There are probably plenty of other differences, but that would be very long to discuss all of them. The feedback also we get from users is that with Webots, they have very good documentation. There is also very reactive user support. There is a growing community of users, and people are helping each other. Yeah, and that's it's easier to get started as well.
Okay, but then you mentioned about porting from Gazebo.
Yep.
They changed from Gazebo, the model of the robot, into Webots. Then, but how did you do that? Because in Gazebo, the model, the way that you define the model is in URDF, but in Webots you have another format, right?
That's right, yes. Actually, Gazebo relies on URDF, which is then translated into SDF before it can be used in Gazebo. In Webots, you can also start from a URDF model. You can convert it to a Webots proto, and we provide a tool which is called URDF to Webots that will convert you. It's a Python script that will convert your URDF model into a Webots proto, and then you can import it into Webots.
Okay.
Clear.
Oh, let me ask you one question very, very quickly. So how do we pronounce the name of the simulator? Because some people say Webots.
I used to say Webots.
Okay.
But it's really open to, I don't care if you pronounce it in a different way.
Okay.
Actually, historically, the idea was to create a web of robot simulation connected on the internet. So it's more like Webots. And then after, like a few years ago, there was this American movie, iRobot. So iBot, and you can say we are the bots. So yeah, it's really up to you. I don't care.
Okay, so I still don't know the correct one.
I like the Webots.
Okay. For me, it's Webot. Okay, let's go.
More questions. A lot of questions, actually. So they ask here, is there integration with AutoWare and autonomous vehicle projects, such as Apollo or AutoWare, with Webots? Is asking this user.
Yeah, so we don't have yet integration with AutoWare. However, we have been working a lot for the automotive industry. We've been working for Renault, for Perron Robotics in the US. We've been working for Magna in Austria, and for PSA in France also. And we provide a number of tools. So we have a large number of cars in Webots. So we have cars, trucks, bicycle, motorbikes. We have urban furniture so that you can create a city quarter with a bus stop, with traffic lights and so on. We have an interface with the Sumo traffic generator so that you can generate a flow of vehicle or pedestrian.
Okay.
And we also have a tool to import map from OpenStreetMap directly into Webots. So you can very easily create maps with roads and bridges and whatever, buildings. And all those tools are quite much used by automobile simulation. Although we don't have integration with AutoWare yet. But it shouldn't be very difficult to achieve, I think.
Okay, very good answers. And it answered also questions from Lucas Macha. So about the integration with Sumo. Yeah.
Nice.
Okay, so let's continue with some questions that I had here. So what is the limit of links that for a given robot that Webots can support? Because from my experience in Gazebo, if you create a robot like, let's say, a humanoid robot with hands and fingers and so on, it gets really, really heavy. So have you done experiments on that? Do you have any info?
Sure. So last year in June, we were contacted by the RoboCup Federation to develop the official simulation for the RoboCup online, because that was COVID time and they had to cancel the real world event. And the plan was to replace it with a virtual competition, and they decided to use Webots because they did some preliminary testing between different simulators, and they found that to simulate quite complex humanoid robots, Webots was apparently the fastest solution. So that's another clue. If you add it to the crawling robot, which was going like 20 times faster than Gazebo, those people from RoboCup decided to use Webots, and they paid us to develop the scenario. So it was quite ambitious because we had to simulate the sponginess of the soccer field and the contact points between the feet of the robot and the grass on the soccer field. And we had like 10 robots simulated on the field at the same time with the ball. So lots of humanoid multi-joints robots. And it was running originally at real time on a fairly powerful computer. And then we added even more complexity with the referee and with many, many rules. And so at the end, it was running like a third of the real time for 10 humanoid robots. And yeah, I think we are reaching the limits of what's possible on the machine. I don't see how we could further improve on such a performance.
And why we cannot improve that? Where is the bottleneck in there?
That was my next question.
Okay.
Yeah, we said bottleneck is accuracy. Then if you sacrifice accuracy, you could get slightly faster, but you have to redesign the physics algorithm. And I'm not sure the result would be very satisfactory.
You mean in terms of parallelizing some physics computations in order to do them faster with more processors?
Yeah, that's another possibility. But as long as the robot come close to each other, it's super difficult to parallelize. Yes. So it's doable if the robots are far away from each other, because they are like independent simulations, so they could run on different cores without any problem. But as long as like you have the 10 robots gathering in the middle of the field and touching each other, then you have to put everything on a single core. And I don't see a very efficient way to handle that.
Yes, I think that is kind of a limitation of the technology itself. So on the physics in computation, so the computation skills.
Of the physics of 10 football players in the same spot interacting with the ball, it would be...
So it's like I think that the bottleneck is in the algorithm. So we don't know how to parallelize this, because the interactions are between all of them at the same time. So they have to share the information, then distribute it between different threads. makes or different processors that makes very difficult to access quickly to the same information at the same time. Okay. So that's a limitation of the current technology in simulators in general, right?
Sure.
Okay, I have a question here. I think that you might have answered partially, maybe. So how does Webots manage the interaction between different elements that compose a robot? For example, grasping. You said that you have a highly modified version of ODE, maybe, and the grasping and so on. It's that basically, right? The ODE modified.
Yeah. We had to fix a number of primitives in ODE for collision detection because they were generating not enough contact points to provide quality contacts.
Yeah.
Because when two bodies collide with each other, they will generate a number of contact points. And this number has to be optimal so that the contact is stable. And originally, ODE was not generating enough contact points, and the location of those contact points was kind of random, and it was not providing a stable collision. Especially when you want to perform grasping, it's super important to have good contact points.
Absolutely.
And so we had to rework quite a lot on ODE to improve for each primitive, that is for boxes, cylinders, capsules, spheres, and so on, the generation of those contact points.
Yeah, I've experimented those problems in Gazebo myself. So, so next question is, how easy it is to create a world in Webots? Are there any tools to build worlds through a GUI or something more user-friendly, maybe?
Yeah, so the tool is Webots, indeed. Typically, when you want to create a new environment for your simulation, I would recommend you to browse all the examples we provide. Like we provide about 100 different examples. So that goes from factory to home to a tabletop environment and also we have cars and urban or highway. There's a huge variety of different environments. So you should first select the one that is the closest to what you want to do. And then you can very easily, from the graphical user interface of Webots, move objects around. You can delete objects.
Okay.
You can add more objects. So we provide a huge library of objects from all categories. So you can insert a new object. You can change their properties, color. You can move them, rotate them, send them the way you want. If this is not enough, you can also import 3D objects. So Webots supports importing objects from OBJ format, Collada format, STL formats. So if you find some object on the web, you can easily import them into Webots. However, if you import those objects, you will get only the 3D shape, and you will have to add the physics property.
The collisions and inertia.
So that's a little bit more of work. And if you don't find what you need on the web, then you can create your own object with Blender and import it in Webots in the same way.
Okay.
Let me ask you one question from the chat, from the audience, that says they are worried if Webots support Ubuntu 22, because this person, Lucas Mendera, he is visiting your website right now, and he can only find the installer for the version of Ubuntu 20.
Yep. So that's a very good question, because we're about to release a new version by the end of June, which will be compatible with Ubuntu 22. And the good news is that you can already download the nightly build of this new version from our GitHub repo. You will find it's labeled R2022B. And if you get this one, it will run without any problem on your Ubuntu 22 machine.
Okay, but it's for Windows, because this is another question from Hassan Hariri, that he says, is Webots installed in Windows OS only, or?
No. We have a different version of Webots. You can install it on Linux, on Windows, and on the Mac OS as well.
Okay.
So you can select whatever version you want.
Okay, so good. What else do we have?
So the next question is a star. So how is Webots integrated in ROS? Is it natively integrated? Does it use a bridge like other engines like Unreal or things like that? The difference is that the first one, basically for the audience, is the first one is native. We just create ROS controllers for Webots or not. So how does it work, basically?
So, yeah, so this is a native interface in the sense that we provide with the ROS packages, ROS nodes, which run on your robot controller. So basically what you have to do is you have to create a robot or select a robot, whatever, and then you have to set the ROS controller on that robot, which comes with Webots. And from there, you're done. That is, the robot will be able to publish topics and message action services and so on. And you will be able to interact with ROS directly. So there's no bridge or no indirect interface. The interface is direct.
Perfect. Okay. And one question?
No, you can go.
Yeah.
This,
so this question is, does it handle ROS1, ROS2? So everyone, so I think you've answered already. So every distribution of ROS2 basically from Foxy, right? And
yep.
ROS1 also from Noetic or even earlier maybe?
Yeah.
Yeah, so
we support, we recently dropped support for Melodic. So right now we support only Noetic.
Okay, yeah, it's understandable.
Okay, then let me ask you another question. Is what does it require from the developer to change in order to have the ROS robot running in Webots? So I have my ROS robot that I'm using Gazebo, and so I have my robot, the real one also, that is on the side here and is running ROS. And then I would like to switch to Webots. So what will be the steps that it will require?
So basically, you will have first to convert your URDF model into a Webots proto. But we provide a script that does it for you. And then regarding the controller, you will maybe, in theory, it should work out of the box like this. In practice, it might be necessary to check the topics and services published by the robot to see if they are about the same as the one you get with the real robot or with the other simulators. And maybe you will have to adapt a little bit and to enable new topics and service to get published. So it's a little bit of tweaking, but it should be pretty straightforward.
But then once we do that, then we can create any node for those robots in a normal sense if we were programming with Gazebo, right? So we can publish, we can subscribe to the topic of the laser, we can publish data to move the robot in the velocity topic and so on, right?
Yeah, basically, we support all the standard topics and services, but in some cases, if you have some exotic topic or services,
like custom,
it may not work out of the box.
Like custom messages or custom services, you mean?
Yeah.
Okay. So let's say that the official messages and services that are in ROS, defined by ROS, for example, the laser scan message. So this is already off the shelf supported, right?
Yeah, it's already supported. Yeah.
Okay, great. So which sensors are supported? Which actuators?
Oh, many. So Webots model, I would say two levels of sensor. We have generic sensors, which are basically the generic devices. And from those generic devices, we implemented proto, which correspond to real device that you can buy off the shelf. So in the generic sensors, I have a list here. We have distance sensors, like sonars, infrared, laser, light sensors, camera with many options for realism, like spherical projection, motion blur, focus blur, random noise, and so on. We also have rangefinders, leaders, radars, position sensors, linear and rotational, touch sensors, force sensors, also 3D force sensors, compass, accelerometer, gyro, inertial unit, GPS, and also communication receiver, so that you can communicate over Wi-Fi or whatever with other
Nice.
robots or with a computer. And for specific sensors, we created a number of proto that are distributed in Webots, but any user can contribute more. Currently, we have Multisense S21 camera, sharp infrared distance sensors, IBU, Okuyo, Robotics, SIG, Velodyne leaders, Delphi and smart micro radars, Microsoft Kinect, and so on. But this library is very easily expandable, and it relies on the generic sensors. And then regarding actuators, the same philosophy applies. So we have generic actuators like rotational and linear motors. We have artificial muscles, tracks, propellers, brakes, connectors. So a connector is a device that can mechanically connect to another and disconnect. We also have displays, so you can simulate a screen. We have LEDs to simulate lights, speakers, so which can play back MP3 wave file, but also we integrated text-to-speech, so it's super easy in Webots to get your robot speaking. We also have a pen device to draw the trajectory of the robot, for example, on the surface. And yeah. And regarding the specific actuators, we have the robotic 3F gripper, which is a specific model of a gripper, which you can pick and plug on your robot design. Okay. But also, you could extend this library with many.
With your own, you mean?
Sorry?
With your own, you can extend with your own actuators or sensors.
I mean, it seems that you have everything you need for basic and not so basic simulations. So.
Yes, exactly. Well, so many years developing, so that's the thing. But this morning we have a speaker from Open Robotics, and he was showing us how to simulate underwater robots and how to use different plugins to simulate the buoyancy and the propelling of the robots. So how does is that possible to be simulated in Webots?
Yes, you don't need any plugin because we already have fluid dynamics included in Webots. So we have some customers who simulated, so we have different things. We have people simulating submarine robots. And then we have people simulating floating robots like boats. And then we have people simulating drones, so it's in the air, so it's not in the water, but basically the physics is about the same. It's a matter of parameter in the simulation. So yes, this is possible in Webots, out of the box without installing any plugin. We have a number of objects like fluid and immersion properties, and you can simply set up your simulation. We have, for example, an example of a salamander robot.
Which is I remember that one.
That one's really cool.
So it's walking on the sand, and then it's getting into the water, and then it's swimming into the water. And it's super easy to have a submarine robot, to have boats, to have drones, to have different kind of drones. We have a propeller device, which can be used inside a liquid or in the air, and it will work the same. And so you can create a drone with this propeller device, but you can also create a submarine with the almost same propeller device. Just have to change a little bit the parameters, but you're done.
So you define then the element and the properties of that element. And then by defining this, then if you put a robot in there, then it's going to actuate based on the physics of those parameters, right?
Yeah.
And that's that simple.
Yeah, but you have to be aware that in Webots, the fluid dynamics model is very simple for performance reasons, because when you want to simulate fluid dynamics, you have two options. Either you simulate it by finite elements, and that's very accurate but very computer intensive, and the simulation will run very slowly. Or you make some approximation, some heuristics, and you have something that is less realistic, but that can run in real time. So in Webots, we choose to implement the second option, which is less realistic. That is, there is no turbulences, for example. But from the experience we have some users using submarine drones, boats, different kind of drones, and they were all satisfied with the results, because you can compensate the lack of turbulences by adding a physics plugin, which will add some random forces and torques, and all of them manage to get satisfactory result, even though the model is not super physically accurate.
Wow. And connecting a bit with a question of the audience from Lucas Macha also, he's asking, would it be possible to simulate machining operations in Webots? And he says, I'm currently working on a research project that aims to use two connected industrial manipulators, and I would like to simulate the vibrations from the machining operation and use it in the controller. So do you know any examples or any work that has been done on that matter?
I don't know, but what is the interest of simulating vibrations? What do you want to demonstrate?
I suppose they want to simulate that when you're machining, there's like vibrations when you're machining the part in aluminium or whatever, and maybe for whatever reasons they need to simulate that.
Because it's distorting the vibrations, is like a force acting upon the tool that you are doing. So they would like, I presume that they would like to take that into account into the controller. But for these, they need to simulate, to tune the controller or something.
So I would say that it should be a matter in Webots. If I would have to do that in Webots, I would simply add a physics plugin that would add some forces and torques to the different part around the place of the vibration. And those random forces and torques would be somehow proportional to the strength of the operation to simulate this vibration.
Okay, yeah, sounds.
Yeah, but then I don't know exactly what you want to demonstrate with this vibration. So if you want to demonstrate at some point the accuracy of the system, how the accuracy will be affected by the vibration, that might be interesting. If you want to simulate how the system will resist to the vibration, if it will break down at some point, then it might be a little bit more tricky. Yeah, I don't know. It really depends on what is your goal with the simulation.
Maybe Lucas Macha can send an email or something with more details. Yeah. Okay. Let's continue with questions you had.
Yes, I wanted to ask you one question about how Webots and GPU collaborate. So can Webots take advantage of GPUs?
Yes, it does. Actually, we rely a lot on GPU for camera devices, but not only. We also use GPU for computing the depths in the LiDARs and in the rangefinders. And it provides a really good...
For doing the ray tracing?
No, we do not perform any ray tracing. Webots rely on physically based OpenGL rendering.
Oh, okay. And you compute all that inside the GPU?
Yes.
Okay.
Okay, then I have a question also. So the rendering engine that you use in Webots for more graphical fidelity, I suppose, do you have plans to make it even better? So doing it with using Vulkan maybe, or some other rendering engine that's around?
Actually, the rendering engine we use is a rendering engine that we developed on our own, and it was optimized for robotic simulation. So we are improving it on a regular basis, depending on the need we have on different projects.
I see.
So basically, it implements PBR physics with stencil shadows, which is the most realistic shadows. We have also implemented optical aberrations. We have implemented flare. There is fog. There is all those PBR material with bump mapping and different texture for different shadow, bump, and effects like that. So that at the end we have also ambient occlusion, which is very important to simulate good quality shadows. So there's a lot of things in there to produce high quality images. However, it's not the same level as a game engine, for example, but it is something which is generic enough so that you don't have to spend too much time in tweaking all the detail of the object for getting a good rendering. You can simply drop a normal object and the rendering will be pretty good.
Okay, great.
It's a matter of compromise.
Yeah, absolutely. You can't do everything.
Everything, yes, it's not possible. It's a limitation at present. Can I ask 2 questions from the chat that they are together? Yes, I think they are together, and actually from the same person. Now that I figure out. So the question is, first one is, among the simulated robots, is from Hassan Harvidi. So from the simulated robots that you provide, are any of them commercially available, so they can buy the robot and then compare with the simulation results?
Oh yeah, many are commercially available. We provide, for example, the model of the EPUC robot, and you can buy an EPUC from us. So we're selling
the EPUC, yes, and also works with ROS2, right?
Yeah. But it also works with the NAO robot, with the Doring OP robot, with many commercially available robots like universal robots, UR5, UR10, and so on.
The robotic arms.
Yeah, many Emika Franca Panda robots. We have many robots that you can buy.
Okay, there is
Spot robots.
Spot also. It's true. We saw yours the simulation.
Commenting that, yeah.
And how did you create this model from Spot? Do you have a Spot?
No, we don't. But there are plenty of models that you can find online.
Okay.
I mean, 3D models. Yes. And then we did a rough estimation for the mass distribution, for the contact properties, and so on. It's not super accurately calibrated because we don't have a real Spot robot to do this calibration. But I think it looks pretty good.
And did Boston Dynamics get angry at you?
No,
for doing that?
No news from them.
Yeah, because I remember one company that once got angry because simulating his biped.
Yeah.
Do you remember many years ago?
Yeah, we got this problem with another company.
With another also. Okay. So finally you had to change the name and some things so it doesn't look like the real one. Okay. Then, so then the second question from the same person is how easy it is to switch from the simulator to the real robot, because in Gazebo, we actually don't care. We just kill the simulation and put the ROS master URI pointing to the computer of the robot, and then we are done. So execute the same code. Maybe we have to tune some parameters. So how is that managed in Webots?
Exactly the same way. You can run a ROS controller in Webots, and then you remove Webots and you replace it with a real robot, and it should behave the same.
And done. Okay, great.
So very easy.
Great. Okay, more questions? Do we have more questions?
Yeah, we have more questions. So how much is Webots prepared to run in the cloud where you have hundreds of processors available? Can we use that power with websites to launch hundreds of robots in the same simulation, I suppose? Maybe you answered this a bit, maybe?
No, I think it's super difficult to run a single simulation with a very large number of robots. You can do it, but it will take very long. However, we have recently worked for some customers willing to deploy deep learning robot simulation in the cloud. And actually, we have developed for AWS some tools so that you can quickly deploy inside AWS 1,000 of Webot simulation running in parallel.
Wow.
And then you can gather the results, and then you can run another iteration of those simulation. So we have all the tools. So we did that for a private customer, but we do have all the tools to very quickly deploy a huge number of simulation inside Amazon Cloud, but any other cloud, basically.
Okay, really interesting that. My next question is, what is Webots animation action? What's its purpose?
Yeah, so Webots animation action is actually a GitHub action script, which is very easy to use. When you have a Webots simulation, which is hosted on some GitHub repo, you could simply add this GitHub action, and every night or whenever you want, it will run your simulation inside GitHub action, so in some GitHub CI machine, and it will record the 3D animation of your simulation, and it will publish it on the GitHub pages. Wow. So that when you come the next day, you go to your GitHub page and you see the 3D animation as it would run in Webots, and you can see the robot moving and doing whatever you program it for.
I imagine it's a video recording, or it's an OpenGL?
Nope. It's an OpenGL animation. So we have some animation format which allows you to play back an animation on the web. So basically, it's a 3D animation on the web. So you can zoom, you can change the viewpoint, and you can see the simulation running, but it's an animation, it's not interactive.
Wow, that's amazing also. And I think my last question is, what are your plans for Webots in the future? So what do you plan for Webots?
So very short term, we're going to release Webots 2022B. So this will happen end of June, beginning of July. And at the same time, we're going to release Webots.cloud, which is basically a web service which allows you to host simulations. So you can view in 3D on the web a simulation. It can host also animations, so a recording of a simulation, as I described. But it will also host interactive simulation, that is simulation actually running in the cloud machine and displayed in real time on the web. And yeah, that will be a big move towards the web, toward the cloud for Webots, and we are really looking forward to see how the community will react to these new features. In addition to this, Webots 22B will support Apple Silicon CPU, that is the M1 and upcoming M2 CPU, so running natively on those machines. It will support external remote controllers, which means that you could start Webots on one machine and start your robot controller on a different machine, and they will work together. We also, it will also support Webots running in a Docker and the robot controller running in a different Docker on the same machine and communicating very efficiently between the controller and the Webots. So this is also necessary for our Webots.cloud deployment. So there will be an improved web interface where it will be very easy from Webots to upload your simulation or recording of simulation to the web. There will be a share button so that you can upload this to Webots.cloud. We will support, as we said earlier, Ubuntu 22.04, but also Python 3.10. And there are, of course, many optimization, many bug fixes, many improvements also coming with this new release. So that is for the short term. In the middle term, we're going to move a robot benchmark. I don't know if you have heard of robot benchmark. Basically,
yes. Yeah, absolutely.
We know.
It's a web service where anybody could program a robot to address a robotics challenge and then to get a performance on that challenge and to get ranked tons of users on this web service. And we're going to move it to the next generation, that is to Webots.cloud. And the big news will be that it will be possible for any user to contribute their own benchmark. Like currently, Robot Benchmark offers about 12 different benchmarks, but you cannot create your own. And with ROS.cloud, you will be able to create your own benchmark.
Wow.
And finally, we're going to organize a robot competition to promote Webots.cloud and the use of Webots. And well, that's it for our plan.
Well, I think it seems like the construct, the rhythm.
Yes,
Like,
we are following the same.
oh my.
Yes.
Wow.
Okay, yeah. So it's
Everything is open source, including the web service technology and so on. So if you guys at the construct or anybody wants to deploy this on their own machine, then you're welcome to do so.
okay. Yeah, yeah. So we were seriously considering this.
Absolutely.
I mean,
absolutely.
before this talk and so on. So because because of the super cool results that we have seen in Webots. But we'll discuss this later, maybe
With a coffee of
with a
Starbucks.
coffee. Are you going to attend the ROSCon, by the way, in Kyoto?
No, unfortunately, I won't be able to make it this
Okay.
time.
Well, are you going to come to Barcelona for the beach, Nita?
Sorry?
Are you going to come to Barcelona to the beach?
Oh, maybe, yeah.
That's okay. That is where I convince you. Okay, so then that's the point where we are going to talk. Great,
Okay.
great, Olivier. Okay, so that's all for today. Thank you very much, Olivier.
Welcome, thank you. It's great to be invited here.
Sorry, you said?
So it was great for me to be invited in this ROS Developers Day. Thank you, Ricardo.
Okay, our pleasure, our pleasure. And then for all the audience, then that's all for this podcast. Then we are going to continue with the conference, but remember that we will have another podcast interview the next week, interviewing a new expert. And until then, keep pushing your ROS learning. Okay, very good. So we are here ready for the next thing that we have to do in the conference. What's the next? Miguel?
So the next thing is reminding you that for each session, you will need to open the corresponding ROSject in order to practice with the speakers in real time. You will find the next ROSject link beneath the live stream. Around,
Now let's see. It's here.
around there,
Okay,
it should appear.
in some seconds, our colleague Alberto is going to put it here and here.
around there.
Yeah, it's the
And-
next speech. So, and the next speech is who is going to be? Is going to be Raffaello
Raffaello.
Bonghi. Oh
Raffaello.
yes, and there we have the project.
There you go. So you
Also-
can launch it.
Perfect.
And don't forget to rate the presentation, but
Yeah,
it's a
that's
podcast, so
it's a podcast. So that you can rate it also.
yeah, rate it.
We'll want to know.
And then, so now you can try to open the ROSject in order to be ready for the presentation. If you get lost for whatever reason, again, go to the Construct webpage, log in, and then in the tab that you have on the top, there will be a button, and you have to click it, and you'll be here again, in case that someone has gotten lost in
At some
in the
point in
process.
time. Yes. And then now what do we have to do? So, before we go into the next one, let me tell you also about the sponsors. The sponsors of this conference are the people that make this possible. And then let me tell you about our ROS2 level sponsor, who is Proxima. You know, the company behind the development of Fast DDS, which is the default DDS that we are using in ROS Humble. Everyone is ships with ROS2 Humble, and is the default one. Then also they have created the Book Nexus, the all-in-one tool for ROS2 development to speed up and simplify some processes. Then we have the other sponsors in ROS1 level, which are
Robotnik, Automation, and Corelix. So Robotnik, automation, creates fantastic robots and sells other components, among other things. And Corelix
is for the robotics brain.
Yeah.
Is the Corelix brain, which is the system that you can put in any robot in order to adapt it to be working on construction sites and help convert your robot into a construction site enable robot.
Yeah, so thank you a lot for
thank you very much.
The sponsorships. And Control Center reports that there's interesting tweets that the audience have been posted. Did you keep posting some tweets? Yeah.
Where you have been doing leaving the conference, attending the classes and so on? Yeah, so we have some of them there.
Wow, this one's a very good setup. I think it's a widescreen.
Yes.
Wow.
It's panoramic and the environment is super cool. Did you do some Photoshop in this?
No. It's those that they are so big like that.
Wow, that's impressive.
It's like now I don't have to go to reality. Maybe.
Yes. Okay, and then even the notes there, the pad with the note. It's very cool.
Wow. Do we have some more? Let me have a look. Oh, pizza. It's pizza time.
What do you mean pizza?
There's a pizza.
Oh, yes. There's a pizza. So, yes, of course, yes, that's the best. The best thing is to have the pizza and a projector.
Wow, very good idea.
Okay, that's in the lunch break. So you were having, that's awesome. Very good.
From Johnny Polanen. Yeah?
Johnny Polanen. Okay. Yes.
And that's it for the moment. So again, if you have any photo that you want to share, ROS Dev Day, right? Hashtag, and tweet it, and we'll try to show it. And we'll choose the best one, the four best ones, and we'll give them a T-shirt like this one.
Like this. Okay, great. So let's continue.